Let's talk about shared pointers. In the previous video, link below the like button, we talked about unique pointers, and I'll just go over really quickly what the difference is between shared pointers and unique pointers. Unique pointers are a smart pointer that owns and dynamically allocate an object and ensures its deletion when the unique pointer goes out of scope. Shared pointers share ownership of the dynamically allocated object among multiple shared pointer instances. So unique pointers when it was just binded to one. So unlike unique pointers, which enforces single ownership, shared ownerships allow multiple pointers to share ownership of the same object. Each instance keeps track of how many pointers are pointing to it, and copies can be made. So if you look at this pointer double right here, we can see that we have, and it can see that we have two other pointers pointing to it. Notice how we get this pointer double 2 and pointer double 3 set equal, both of them set equal to pointer double. The reference count is increased per copy. So if we made a pointer double 4, we would have 3 references that it would know of. Just like unique pointers, we have automatic deallocation, which means when it goes out of its scope, the memory is deallocated. For the most part, we're going to talk about circular references in a second and how they can cause a problem with us. They're useful in scenarios where multiple parts of code need shared ownership. Like I said, with unique ownership, once you go out of that scope, you're done. But if you want to reference things from a different scope, you can do this with shared pointers. However, it comes with overhead because it can continue outside with the circular references, which is what we want, but also not what we want. It could lead to memory leakage, so use unique whenever possible. Now, let's talk about circular references and how we can resolve that with weak pointers. So circular references essentially are memory leaks. Shared pointers that are weak use these to break circular references. So if it's a weak pointer, there's no direct ownership and only a weak reference to the object, instead of ownership like what our shared pointers have. The object and pointers can be observed without affecting its life within the program. So let's say I want a double 4, pointer double 4, but I want it to be a weak double. I don't want it to be directly linked. We just have to do weak pointer instead of shared pointer. Now most of the aspects are going to be the same, it's just a difference in how it's pointing or linked together. You can see I'm still setting it equal to our pointer double right here, and our name is just weak pointer double 4, and the data type is double. There's a few things you can do. You can see if our shared object is still alive, so that would be if our weak pointer double 4 is expired. If it's not expired, we would want to go inside of this if statement. Would definitely need another parenthesis there to close off that header. To access our shared pointer from the weak object, what we're going to need to do is a lock. So locking is a shared pointer that is locked to a shared object, and we get this through our weak pointer. So we have our weak pointer right here. Let's try to lock it. So we want it to be a shared pointer. So we'll do shared underscore pointer. The type is going to be a double, and then we're gonna just have our weak pointer double 5. And we don't want to set it equal to pointer double though. We want to set it equal to our weak pointer, and then it should autofill up, but if it doesn't autofill, we'll just autofill it ourselves, or we'll manually fill it with weak pointer double 5. You notice how there's an error here? It's because we need to lock it because it's trying to convert it. So we have .lock method right here, and that's going to give us access to what we have here. So let's go back up here, and underneath this we will assign our pointer double to be equal to 3.14, and then we can come down here and we're just going to see out, and what we'll print is our value at weak pointer double 5. You can see we put in 3.14 up here. We made all of these references to it, and even though we put it as a weak pointer, since we have locked it, we can now view that value, and you'll see that we have 3.14. And that's going to be it for our shared pointers as well as weak pointers. Beware of circular referencing. Use weak pointers to remedy this. Remember, they have locks, you can see if they're expired, and there's other things you can do as well. These usually have automatic deallocation. Just be aware, since shared pointers share ownership, they can have that circular reference issue. If you have any questions on the material, please leave a comment below, and if you want more C++, check that playlist link below the like button.